Recording in progress.
All right, let's start. I'll be doing the laws again. So we'll be basically solving questions using the laws. আমাদের aim হচ্ছে আজকের মধ্যে lawটা wrap up করা. Okay, then I'll only need 3 more classes to wrap up electricity. So দেখি কি করতে হয়. So this is the question. I'll start from scratch. Last class we didn't even find the answers. So প্রথম থেকে বুঝাই কি হচ্ছে এখানে. So what you have here is a circuit, right? And you have a resistor here, there. You have a battery here, battery there. And the currents provided are I1, I2, and I3. Okay. Now, a couple of things before we start. Number one, you can't classify this as series or parallel. Okay. Because এখানে তুমি যদি এইভাবে নাও এটা কিন্তু সিরিজের মতো বোঝা যায়. But then there's another battery forcing current from the other side. So eventually, these circuits are not your classical series or parallel. Okay, which is actually a good thing. Because Kali series or parallel circuits fine in real life. It's usually something like this, right? Now, problem is that how do you find it? So imagine you didn't know these laws that I showed, right? Loops and whatever. How do you find the answer? Attempt করতে গেলে you will be always stuck somewhere. I'll explain. For example, if you try to take current through this place, right? A typical O-level student কি করবে? V equals to IR করবে, and they will think I3 is the current here, right? And a mistake that they'll do is they'll think that the current is going to be same like that, but it's not, because what do you have here? A junction, right? Doesn't that naturally mean that the current here and the current there and the current there must be something different, right? So you can't assume that the current is same in this whole place. You can't assume that the current is same there either. Now you might, as some students try to form equations like simultaneous equations, right? But it becomes I1, I3, I2. There are 3 variables out there, right? Eventually, answer আসতে পারে. I'm not saying আসবে না, but the thing is, it might be a dead end. We don't know. Okay, so how do you solve these kind of questions? There's a very easy way out there. Okay, we apply the Kirchhoff's second law. The second law কি বলে? Second law বলে that if you take a closed loop anywhere in the circuit, right, the sum of EMF must be equal to what? The sum of PD. So if you keep adding all the EMFs out there, it must be equal to all the PD out there. So any loop, by the way, there is no exception here. So what are the loops out there? It last class was a struggle. This is one loop, right? That this one is a loop here at the bottom. And the one that is actually very helpful is the whole thing can also be taken as a loop. So the number of loops is not limited to just the smaller boxes. You can take like a bigger thing as well. Okay, so how do you approach this, and why would I take the bigger loop? So the thing is, let me explain. If I use this loop here, the smaller loop here, I'll find that there's a bit of an issue here. What's the EMF in this loop? Can you tell me? A loop what's the EMF? 6, right? Because EMF is what feeds the circuit. And what are the potential differences here? The 30 and the 10. Now, if you do the math here, and for PD was the formula V equals to IR, right? The current is I3 here, and the resistance is 30. So that's fine. I3 into 30, right? But what's the current there? Is it I3? Yeah, I1, right? So you have plus for I1 into 10, and all of that is supposed to be equal to what? 6, right? That doesn't give an answer. And you might feel maybe there's a simultaneous equation somewhere coming up, right? Most of the time, point at that. So here we are not getting the answer right away. Let's look at the loop at the bottom. This is reactive. It looks like a perfect circuit. Look at that. That's just a normal circuit, right? So if you do this here, the 2 volts is the EMF, right? And what is my AED in this loop? Just that, right? So what should be some of EMF is 2 and some of ED. And this will give you the value of what? I3. So actually, I3 which we have where I want there. What can I find from there? I1 and once I I1 and I3, what can I find? Yeah, use what? The Kirchhoff's current law. I1 is equal to I1 plus I2 plus I3, right? You get my point. Now you could have taken this full loop as well. If you could have looped, you could have find what at the start. I want and how you get this whole loop here. And I want you to learn this loop. If I follow this loop here, right? one mistake some of the students do is they think that the 6 volt and the 2 volt are actually the same direction. Are they in the same direction? Right? Isn't this one's current in that way and that one's current in the other way, right? So tomorrow you can actually net EMF বের করতে হয়, it has to be either 6 minus 2 or 2 minus 6, right? মানে the net, right? So ওইটা যদি use করো and you follow this loop, can you tell me what's the only PD here? What's the only potential difference in this circuit? Say data I1 10. So what can I find from here? I1 as well. So এখান থেকে I1 বের করতে পারো, এখান থেকে I2 বের করতে পারো, sorry I3 বের করতে পারো, and then you can find I2. মানে there are many ways out there. Also Kirchhoff law তে একটা advantage হচ্ছে there's no one way of solving it. You can take different approaches out there. So আমি start করি solve করা. So first of all, loop গুলোকে নাম দিতে হয়. And again, before I start, big disclaimer, A level of difficulty question past paper and 9. Where did they get this question from? Your textbook. So textbook guide you should use for to say past paper questions are way easier. I'll show you some of them. They're like extremely easy when it comes to this law. Okay. So I mean a question will Karachi just based on the information provided by the textbook. Okay. So this is loop 1, this is loop 2, and this is loop 3. Why is I1 flowing through 10? Acha, good question. I1 can flow because I1 goes here, splits up into I3, and there's I2. Tapor whatever happens here, the amount of current that has to come back to the battery has to be what again? I1. But the amount of current that leaves the battery will always be same as the amount of current that comes back to a battery. No exception ever. Okay. So if I take loop 2 here, okay. So let's do this in loop 2. And whenever you take a loop, first sum of what? EMF is equal to sum of potential difference, right? Now, what's the EMF in loop 2? 2 volts, right? But the question is, should it be plus 2 or should it be minus 2? Plus 2, why? Very good, right? Do you see that the current from the battery comes out this way? And do you see that I took my loop that way? So isn't the current of the battery and my loop the same direction? Tell plus hobe. What if I had taken the loop the other way? Is that a mistake? No, right? Perfectly fine answer. Just tomorrow key hobe eta minus 2 hobe, okay? It's like taking left and right in a mechanics question, plus minus. It's up to you, right? So ekhane EMF hocche 2. What's the potential difference here? So আমি যদি এভাবে যাই, like if I follow the loop direction, does the loop direction and the current I3 provided by them have the same direction? Yes. So my current will be positive or negative? Positive, right? এরকম যদি হতো আমার লুপটা এভাবে ড্র করছি and the current they have labeled this the other way, right? What would I take? Minus, right? So in this case, this is going to be I3 times 30. So from there, you get your I3 value, which is 2 by 30. কত আসে 2 by 30? One by 15. So we have our I3. আচ্ছা একটু দেখেন আমি পুরোটা করে নিই আমি আরেকটা কোশ্চেন দিব তোমাদের কাছে করার জন্য সো একটু কেয়ারফুলি বুঝে নাও we don't have that many questions so বুঝে শুনে করতে হবে loop 3 তে যাই একটু so in loop 3 sum of EMF is equal to sum of PD once again can you tell me in loop 3 what is the EMF going to be based on the arrow I have selected and based on the arrow of my loop what is the EMF চিন্তা করে বলো should it be plus 4 or minus 4 minus yes very good because আমার লুপটাতে 2 ভোল্টটা পজিটিভই থাকবে প্লাস আমি এদিকে যাচ্ছি এটার কারেন্ট কি উল্টো দিকে বের হচ্ছে না so am I not taking my loop against the flow of current so এটাকে আমি কি কনসিডার করব -6 equals to there's only one potential difference here যেটা আমার কারেন্টটা হচ্ছে এভাবে যাচ্ছে I3 sorry I1 have I taken the loop in the direction of the current that is supposed to be or is it against the current that's supposed to be মানে বুঝছো যে কারেন্টটা ন্যাচারালি এদিকে যাচ্ছে না আর আমার লুপটা কি ওদিকে যাচ্ছে না should it be plus I1 or minus I1 minus right so minus I1 into 10 এটা করলে তুমি I1 এর ভ্যালু পাবা দেখো তো কত আসে 0.4 ampere so you have your I1 and you have your I3 so now I2 is very easy I2 তে কিছু ইন্টারেস্টিং হতে পারে একটু দেখো So I2 কেমনে বের করব? So I1 plus I2 should be equal to what? I3, right? Based on what law? Kirchhoff's first law, which states that the sum of current at a junction is equal to 0, or total current in is equal to total current out. So what's the total current in at the junction here? I1 plus I2. What's the total current out? I3. So I1 plus I2 equals I3, right? What's I1? 0.4. What's I2? Now we're trying to find I2, I think. I3 is what? 0.067. So you can take I2 টা আসে, দেখো তো কত আসে। Negative 0.33. Why is our answer negative? Right, I'm only key problem এখানে কোনো problem না. This is actually something good that happened. Do you see that the label of I2 was given like that? Right, it was just a label, it's a placeholder. আমরা তো জানি না actually current কোন দিকে. Turns out, if I had taken the direction they had mentioned, the current turns out to be what? Minus 0.33, which indicates what? That the actual current is not in the direction they have labeled. Which way is it? The other way. And it makes sense. I'll tell you why. Do you see this battery has 6 volts? Do you see this battery has 2 volts? Do you think this 2 volt can override the 6 volt that's coming from that side? Unlikely, right? So shouldn't the net current here be something like this and something like that? And you know, our math proves that the current actually in the lower branch is the other way around, not in the direction that they have mentioned. Okay, and this is fine. এটাকে চেঞ্জ করো না, অনেকে ভাবে যে নেগেটিভ হবে না, let's just keep it positive, right? That's wrong. It should be negative. Okay, right, so there you go. Typical question from this chapter, মানে এখান থেকে টেক্সট বুক থেকে পাস পেপারে এরকম কিছু নাই. So that's again বলে রাখতেছি, we don't have really that many questions to practice. বইয়ের আরেকটা আছে, ওটা পড়লে will be done. So yeah, to যাও copy করে নাও. I will give you another example next. Are you guys done? আচ্ছা, তাহলে আরেকটা example করি. Today we'll be doing one more example and a couple of derivations before we can move on to the next topic. Try this, find I. Should have an answer now. 0.5. Just one. R2. 0.1. Are you using 0.1? That's too low for this circuit. Acha, crazy. Let's not part it to saddle because it's a very easy question. Okay. It's just what loop have you taken can make a big difference. Okay. So if you take this loop here, let's say, a loop you try koro, answer power impossible. Okay. Cannot emboli. Is the current through this wire I? No, right? So তুমি যদি এটাকে একটা সিরিজ সার্কিট বানায় কোয়েশ্চেন সলভ করার চেষ্টা করো, that's the wrong answer. Okay, এটা হবে না. If you take this loop and do your math, it is actually possible. Okay, and I'll show you. So we'll call this loop 1. আর কি কোনো loop আছে এই diagram মধ্যে? Yeah, the whole thing, right? So you can take this whole thing here, right? So that's loop 2. So তুমি যদি loop 1 or loop 2 নিয়ে করো, you should get the answer. Let's see. So in loop 1, loop 1 টা কোনটা? Loop 1 is the I'll highlight it a little easier হবে তোমাদের. Loop 1 is basically data. That's loop 1, right? So can you tell me in loop 1 what is my sum of EMF? Loop 1 এ কয়টা EMF দেখা যাচ্ছে? দুইটা, right? আচ্ছা. So what's the sum going to be? By the way, I've taken my loop in that direction. Acha. So what's the sum? 5, right? Plus 5 na minus 5 part. Plus, because do you see this drives current that way? This also drives current that way. Mane a loop direction korteche na. So what's my total EMF going to be? 5 plus 5 equal to, is there a potential difference across the loop? There is one, which is what? Just 10, right? So 10 times I. So I is equal to 1 ampere. Okay. Now, if you had taken some other loop, same answer. Let's take the blue loop. So blue loop jodi nei, in this case, you'd find this whole thing. Blue loop this whole thing there, right? Do we get same values or not? Let's see. So what's my sum of EMF in this blue loop? Here, sum of EMF in the blue loop. Same. 5 plus 5. We just idea of 5 versus so 5 plus 5 equals to what's sum of PD here? Here, I'll just try for you. এখানে কি হবে? I times 10 plus এই যে নিচে যে 10 টা is the current here I or something else? Yes. So এটা হচ্ছে not possible, right? আর কোন loop ছিল possible না আমার মতো? Oh yeah, the first one এখানে, sorry, is it this one? এটাও same, impossible. আচ্ছা. So if you look here, I think তাহলে একটা loop possible. Which one? The middle one. Okay. So what's the trick that you have to look for in order to get your answer right? Whatever loop you take and you're trying to find a current, right? Just make sure that that loop only has that current. If there are multiple currents out there, maybe we could have done this simultaneously and answer Ashton, not saying Ashton, but look for the easy way out, right? Easy way out, find a loop where there's only one component, right? And the current is the one current that you're looking for. Why didn't I take which one? The 10. This one. No, I tried to take it, but the problem is that if I take this 10, right, what's the current through it? I is the current that comes out here, divides, comes back. It's I here, not there though, right? Achha, so we'll do one past paper question and the idea of what's actually expected, and then we will do the derivation today. Right, so this is your typical past paper question from the Kirchhoff law. তোমাদের যখন লটা করাইছিল, I remember you guys had some trouble. Do you still have those trouble মানে স্কুলে যখন করাইছিল? Problem তো তোমাকে বলো. I mean, I remember some of you had done this before I did the chapter, right? So if you have found any confusion back then, you can clarify those for me. Here. This is a past paper question, okay? Try করো. Marks দেখে তোমাদের একটা hint হওয়া উচিত that it's not that difficult. 1 mark করে সব। Done. Right, so let's see. Shobashesh. Right, it says that two cells E1 and E2 are with negligible internal resistance. A phrase term মানে কি next class বুঝে যাবা. We'll be doing internal resistance next class, but আজকে it doesn't matter, so you don't need to worry about it. Are connected as shown here. The currents in a network are indicated here. Use Kirchhoff's law to state the relationship between I1, I2, and I3. So what's the relationship between I1, I2, and I3? এই জাংশনটা নিয়ে করলে বেস্ট হয় কি হবে? I1 plus, right, I1 plus I2 is equal to I3. However, my recommendation is that you can write this in another way based on the definition that Kirchhoff actually provided. What would that be? Yeah, exactly. It's just what was the version that Kirchhoff said? That the net current at the junction is what? 0, right? So net current key over I1 plus I2 minus I3 is equal to 0. Okay. I have seen that they have not mentioned anything about whether they'll accept the other or not, right? So just to be safe, write that one. It's just simplifying your equation. Okay, next হচ্ছে the EMF that is between E2 R2 কোন লুপ এটা BCXYB BC x y আচ্ছা এই ছোট লুপটা রাইট সো এই ছোট লুপের জন্য ওরা ইকুয়েশন চাচ্ছে and do you see that ওরা কেমনে হচ্ছে alphabets they tell you which way the loop should be right so their loop is going this way so what should it be positive e2 or negative e2 yep negative e2 so minus but I'm doing sum of emf equals to sum of pd right r2 emf নাই এখানে so minus e2 is equal to minus i2 r minus i3 r তোমরা কেন বুঝছো কেন সব minus is the loop that I'm taking সবকিছু আমার লুপের উল্টা right which means it can also be written as what e2 equals to i2r plus i3r okay both of these are correct are you with me that's okay next হচ্ছে a b c x y z a b c x y z also the whole thing okay so they want an equation based on the whole thing আমরা লুপটা এবার উল্টা দিয়ে নেই না এটাই ব্যাপার না so কি হবে what's the sum of emf here should be e1 if I take my loop that way আচ্ছা should be e1 minus e2 or e2 minus e1 yes correct e1 minus e2 should be equal to আমার লুপের সাথে i1 ম্যাচ করে so i1 r কিন্তু i2 ম্যাচ করে না so minus i2 r আর এটা কি হবে yeah that's i1 actually okay so plus নাকি minus plus i1 r so eventually কি হবে e1 minus e2 equals to 2 i1 r minus i2 r okay and that is what your questions are okay so তোমাদের এক্সামে যে এই Kirchhoff law থেকে যা কোশ্চেন আসে এগুলা আসে that's why I said যে I had to go to the textbook to find these stuff because এগুলা আসে না এই যা আসে হবে and it's the same thing actually মানে you know if you can figure these out and there are numbers provided you put the numbers here you get the answer right so it's not going to be like a surprise if they do actually give a question with numbers they haven't but they may okay right why e2 minus e1 sorry e1 minus e2 because I'm going this way my loop is this way and e1 is feeding current in that direction and e2 is feeding current in that direction so they're opposing each other so the net emf would be one minus the other bolo why did I take i3 minus because for part b like here I took my loop like this so if I go like that if I go like this and then if I go like that with my loop does the current i3 match my loop or is it against right so whenever your arrow and the actual arrow provided are in opposite direction the current will be a minus and if your arrow and the actual arrow match it will be plus okay so questions থাকলে বলো anything you will face issues here it's not like just a tricky the thing I told you earlier that when the theory is very simple they will compensate that with what complicated questions আচ্ছা so এটার MCQ গুলো একটু ঝামেলা হয় MCQ গুলো ঝামেলা হয় মানে হচ্ছে I'm not saying it will be complicated in anything we have done but students seem to have confusion with the plus and the minus and stuff like that okay so just once we start doing our MCQs you'll find some questions that might be a little tricky okay but I saw that you guys found this one manageable remember last class we did a current question যে essentially এই টাইপের কোয়েশ্চেন আসে ওকে এরকম প্লেন্টি আছে সো এগুলা যদি বুঝো তাহলে যেগুলা দেওয়া এক্সাম্পল গুলো বুঝবা অলরাইট right so let's wrap this topic up এটার জন্য হচ্ছে what you need to do is page 94 এর পাশের blank page এ heading দাও derivation of series and parallel resistor combination Right. So at your screen, can you tell me in this circuit based on Kirchhoff's second law, a relationship? So what's the Kirchhoff's second law? Sum of EMF should be equal to what? Sum of potential difference, right? I mean, first law use করতেছি না এখানে reasonটা বলি. First law I think কিছু করার নাই. Is the current getting divided anywhere? No, right? So if I have a first law here, what is it? I1 equals to I1. And that's it, right? There's nothing else happening here. But second law, we have some stuff going on here. So can you tell me what is the EMF here? E. Yeah, so that's my E. And what's the PD going to be? I1 R1 plus sorry, I R2 plus I R3. Do you agree? That's clear too. Okay, so now what we're gonna do is a total J EMF ta eta ber korte jacchi amra. So total EMF er jonno what can I do? So if you use V equals to IR, right? V equals to IR, and voltage jodi total nawa hoy, current ta ki dibe amake? Total, and resistance ta ki hobe? Total, right? So can I not replace my EMF with total current, total resistance, right? So if I do that here, I get I total is sorry, into R total equals to I R1 plus I R2 plus I R3, right? Now in this circuit, what is I? Same, right? So I total is equal to I, and that being same means what can I do to the I's? Cancel them out like that. And once I cancel them out, what do I get the expression for R total to be? R1 plus R2 plus R3. And isn't that the equation for the combination of series resistors, right? So that's how it shows up. I know for O levels, we used to take it granted and just pashapashi we add it, right? But there has to be a logic behind this. This is the logic behind this, right? So this series derivation is actually based on what law? Which law? Second law. More importantly, MCQ journal, it is based on conservation of energy. Conservation of energy. Right. So that's the series version. আমি প্যারালালটা করে নিই, তারপর আমরা দুইটা একসাথে কপি করে নিও। Parallel একটু দেখো, how does the parallel one go? Very similar. So you have your branches here, current একটা, and we have those individual branches like this. Right, so this is R1, R2, R3. These currents can't be I. So they're I1, I2, and I3. And the voltages here would be V1, V2, and V3. Do you understand the circuit? Very basic. Can you give me an expression in terms of I1, I2, and I3? Which law should I use? First law, right? So based on first law, sum of current at a junction is equal to what? 0, right? So did you apply query? What should that be? I should be equal to what? I1 plus I2 plus I3. You guys seem a little skeptical. Here's all. Can monocholina. Isn't that what the equation should be? I comes here and splits up into three parts, right? Shouldn't I be equal to I1 plus I2 plus I3? But anyways, now what is the formula of I in terms of Ohm's law? V by R, right? That's going to be V total by R total equals to V1 by R1 plus V2 by R2 plus V3 by R3. Now, this is a parallel circuit, and in parallel circuit, what is same in every branch? Voltage, right? So if all your voltages are equal, I can cancel these voltages out, and therefore I'm left with what? 1 by R total equals to 1 by R1, and that's how this equation shows up. Do you understand? Right, so can you tell me which conservation law is this based on? Yeah, charge conservation. Sorry, the 2 R1 into R2 divided by R1 plus R2. Yeah, it's fine, but it's only for how many resistors? 2, right? But this form is for what resistor? Yeah, and normally in AS we do get more than 2, so therefore sticking to this is better. Right, there you go, the two derivations. Charge conservation. Yeah, bolo. In conductors, yeah, in everything.
Why do they go in the same direction?
Same direction. No, they don't. So I'll clarify something here. When you mean charges are moving in the same direction, right? What charge are you referring to? Electrons, right? And moving same direction, Manu? But didn't we learn that the electron movement and the current movement are always opposite? Positive charge carriers, they're holes. And positive charge carriers are actually not charge carriers. I'll explain that. But I understand where this is coming from, but it's not really a part of our A syllabus. We used to have this in EE. It's about intrinsic material. It's not that complicated though. So the idea is that if you have an atom here, right, and the atom has 4 valence electrons out there, right? What you do is you take another atom, right, and add it to it. And as you place another atom here, let's say that has 1, 2, 3 valence electrons, right? So what is the total electrons that you have here? 7, right? Isn't there a hole left behind that an electron can fill up? So isn't this atom as a whole, right, attracting an electron towards it? So I'll show you what happens. It used to be there in our syllabus, which I get advanced older about this. So semiconductors, right? They have this weird mechanism. Remember, talk about doping. Intrinsic, extrinsic, So essentially what happens is you have an electron here. And this electron is going to move around, right? So as this electron enters this, right, and then goes this way, which is the electron moving to the right? But if you look at the number of holes out there, you'll notice that, let's say these are all filled up like that, okay? So if the electron goes this way, and this electron jumps here, and this electron jumps here, right? Which way would you see the hole move? The other direction. It's very similar to, like, let's say in a theater, right? There are chairs and there are people in the chair. The people are moving to the left. The empty chair is moving which way? To the right. That empty chair is considered like a positive charge moving, but it's not really a positive charge moving. Positive charge can't move in the first place, right? So it's an illusion, if you could say. And this happens in semiconductors. And this whole movement is considered positive charge movement, and the electron movement is called a negative charge movement. So that hole is what actually creates the diode effect, that they can go one way, and once you block the hole, they can't really go that way. But we don't have any of these. Okay, so ওইটা নিয়ে worry করো না. Right, so এখানে হচ্ছে couple of things that I need to show you. This is extremely useful একটা জিনিস যেটা এখন দেখো তোমাদেরকে. You probably know about this, but আমাদের syllabus-এর মধ্যে the questions are designed keeping these in mind. I mean, to explain করি তোমাদেরকে, listen carefully. So MCQ যদি করো, and I don't know how many papers you have tried so far. The challenge in MCQ is usually time. Okay, it's the biggest challenge. Question, I mean, 2 hours, 3 hours a day for an MCQ paper. Eventually, you will do, on average, better. You won't get everything right, but you'll do better, right? But the problem is with that time frame and the type of questions they provide, right? It is very common that students don't get to read all the questions. Okay, I've had scenarios where students end the paper at question number 28 because they just didn't have time, right? So এখানে কোথায় প্রবলেমটা হয়? প্রবলেমটা হচ্ছে they spend too much time obviously on each question, and you have 1 minute 4 seconds for each question. So ওই 1 minute 4 second যদি পার হয়ে যায়, right, you're eaten into time of what other questions out there. So যখন we start discussing papers, I'll try to teach you techniques to avoid that. ওরা কিন্তু trap set করে. There are some questions that are just straightforward traps for you to what eat up your time. এবার কোয়েশ্চেনটা এত বড় একটা wall of text, তারপর ওটা পড়ে টরে তারপর এমসিকিউটা সলভ করতে হবে। মাই অ্যাডভাইস আগেতে বলে দিচ্ছি, স্কিপ দ্যাট। ওকে, মানে ওইটা পড়তে যে টাইম যাবে, you probably would be able to solve 3 radioactivity questions at the end, like what's an alpha particle. But তুমি যদি ওইটা পড়ো and answer করো, most likely wrong হবে। মানে that's how it should is usually. নাহলে এত বড় wall of text দিত না, unless it's an easy question, and you miss out on those 3 questions at the end, right? So ওইসব কিছু strategize করতে হবে আমাদের। I'll explain. They're not very complicated, they're common sense stuff, but there are a few things you can apply to make some very complicated questions very easy. A resistor অনেক কাজে দেয়। So resistor, we have seen this in O levels, but O levels the question goes to খুবই basic, so লাগতো না, but A levels you can actually use these, which is whenever you have a series combination, right, and you have resistors R1, R2, and R3, the R total will always be, and this is a no-brainer, greater than any of these R1 or R2 or R3. Does it make sense? Yeah, because when you add them up, they will be definitely more than anything else in the combination. But parallelly, there's an interesting thing. Parallelly, when you have your resistors connected like this, R1, R2, and R3, right? The parallel combination of these 3 resistors will always be what? Yeah, so R total is going to be what? Yeah, less than our lowest. বুঝছো? So আমি যদি তোমাকে বলি this is 1, 10, 1000 without doing math, what should the total resistance be? Less than 1. You can try this. It's going to be 0.9 something. Okay, so why am I saying this? It's very easy to imagine that when you keep adding resistors, right, what happens to your combination in order to explain other behavior, right? So we understand that adding R in series কি করে increases our total, adding R in parallel কি করে? If I keep adding R, right, in parallel, what happens to the total resistance? Decreases, right? Because you're just adding, and then the lower value you add, the total resistance will go lower than that. Okay, so your decreases. Now another useful tip out there, এটা খুবই useful. Once you notice it, you'll realize that they actually have been trying all along to help you guys out. You guys just never saw it. So ওরা কি করে, ওরা এরকম branch দিবে with lots of resistors out there, right, like that, and it might feel like it's a trap to consume your time, right? দেখো কি দিচ্ছি আমি এখানে। So yeah, this is the circuit that I have. এটার সাথে আমি এটা কানেক্ট করব, okay, and এটার সাথে আমি R এটা কানেক্ট করব, resistor, and তোমাদেরকে টোটাল রেজিস্ট্যান্স বের করতে হবে। আমি বলতেছি কি করতে হবে, জাস্ট আ সেকেন্ড। তোমাদেরকে টোটাল রেজিস্ট্যান্স বের করতে হবে। These are all 10, okay? We're 2.5. What's the total resistance? You have 10 seconds. No, I want a value. What was the total resistance? 10 seconds. Next. 10. Wait. You can restart. 5. At a 5 chilo. Yeah. Oh, nicheta. 15. No.
Is it zero expectation of incarceration?
25. No. Acha, time's up. Answer is 2.5. How do you find 2.5?
4 by 10 plus 4 by 10.
4 by 10.
Yes. And then we go there.
আচ্ছা আমি বলি কি এখানে শর্টকাট ইউজ করা হচ্ছে look at this what is the total resistance of this combination কেমনে বের করবা 1 by 10 plus 1 by 10 এরকম করে করতে হয় না the rule is শর্টকাটটা বলি যেটা ওরা actually apply করে the rule is that the total resistance of a combination like this where all the resistors are identical is R divided by N মানে তোমার যে resistor divided by the number of branches you have. So if you have identical resistors in any question, right? Definitely they're applying this rule out there. So what's the resistance of one resistor here? 10. How many branches do you have? 4. So what should the total resistance be here? 10 by 4. How much is that? 2.5. এইটাও কি হবে resistance of this combination? 2.5. 2.5 and 2.5 add করলে কত হয়? 5. 5 is parallel to 5. Again, that rule can be applied. What should the total resistance be? 5 by 2. What is it? 2.5. Okay. Watch out for it. And I'm glad they do this because it's very useful once you get a hang of it.
Recording stopped.
After like the 20 classes, can you like more than one class? So like in 1 hour, it's like very efficient. It takes like 20 minutes for us to settle down and start the experiment.
Yeah, I think from February we'll be having 3 Saturday, Monday, Wednesday. Saturday, Monday, Wednesday. Two classes a week from February, and then March, April. I think there's another person who will be there, so you can come and do your practicals.